All right. Hello, everyone. Welcome to today's installment of the Corundum Developer Meeting. Thanks for taking the time to tune in. All right. So let's see. The agenda for today mainly is status updates, and then also a quick announcement. The next meeting will be January 16th. We're going to skip the one on January 2nd because, New Year and whatnot. So, yeah, pretty straightforward. Figured I would get that out of the way right at the beginning, so anybody watching this will be aware. All right, so let's see. Status update summary. A quick check-in on the status of a couple of the last major bugs that that I'm aware of anyway. Then a brief word on priority flow control. Then update on the AXI virtual FIFO that I've been working on. And I think everything else here is pretty much just the carryover stuff. I have made a couple of tweaks to the DRAM integration stuff just as I've been working on testing some of the AXI virtual FIFO code, but I don't think I've made any changes to those slides. So, all right, not all that much new. Okay, so the PCI Express hip bug, this one, like I said, I have this implemented in the HIP model, but now I need to make some updates to the DMA engine and whatnot. But this is backburnered until I get back to working on the descriptor fetch and variable length descriptor improvements, because that seems to trigger the bug under normal operations. Doesn't seem to be a problem. So yeah, nothing new there. Let's see, for the FIFO memory inference issue, this was a problem on the Intel devices where we were seeing weird issues with the checksum computation module on TX. The folks at MLE traced this to Quartus doing something weird. It was reported to Intel. I don't know if we have any updates on that. Ulrich, Joachim, do you guys know if there's been any movement on that? Or I know you said it was reported to Intel and they were working on it on their end, but
Yeah, right. The last update in the bug tracker is from, I think, exactly 2 weeks ago. No, actually 1 week ago. So they were able to reproduce issues in a more narrowed down test bench,
okay.
and yeah, they're working on it.
Okay, well, that's good to hear. So maybe in a few months we'll have a new version of Quartus that fixes the problem. All right, but they agree that it's definitely a Quartus issue, a tool issue.
I guess that's not what they wrote so far. They just confirmed that they see
That they see the
issues between the
same, but they
two
haven't tracked down.
implementations.
Okay.
Yes, exactly.
All
So
right.
they're still tracking down this, but they might correlate this, or they see either an additional thing which we haven't seen yet, or they correlate it with another already existing known thing. But yeah, there is no more details available for this.
I
So
see.
yeah,
All
let's
right.
see.
Well,
I guess they are more or less on Christmas vacations, or usually there is like super high priority stuff that needs to be finished before end of the year. And I guess, yeah, we'll get an update in the next year then.
right. Yeah. Okay. Well, that's good to know. That there's actually movement of some sort at Intel with regards to this. So, all right. Cool. Well, that's rounds it out for the bugs. Now, the next thing is priority flow control. We're starting to take a look at implementing priority flow control in Corundum. And Antonio, who's on the call right now, is a PhD student at the Spanish university. I'm drawing a blank on which one. It was UCLM, I think. Can't remember what that stands for at the moment. But he was interested in doing some stuff with PFC and offered to help do some of the implementation. So it's like, all right, well, let's sit down and figure out exactly what needs to be done, and then we can get cracking. So on the hardware side, kind of this is a summary of what I think we need to do. we might need to do some more stuff. I'm not sure. On the hardware side, we need to implement just sending and receiving the PFC pause frames, along with managing the pause quanta counters, both for refreshing the pause frames on TX and reacting to the pauses on the RX. But just being able to send and receive pause frames is not really sufficient, right? You need to be able to send them under the right conditions and do the right thing when one shows up. So for that, we need per TC queuing of some sort. And then once we have the queuing, we then need to connect the fill level of those queues effectively to the PFC frame logic for the generation side. And then if we receive a pause frame, we need to pause the queue. So those connections need to be made, and then we need some sort of internal flow control, which will make sure that we don't have head align blocking inside of the core data path, because I don't think it makes sense to add a separate data path per traffic class. Restricting that to just queuing, I think, is going to make a lot of sense. But if it's just queuing, then you got to make sure you don't have head align blocking between the different traffic classes. And then finally, we need some sort of TC aware per TC scheduling, such that we can actually schedule things appropriately in the TX direction, again, to avoid things like head align blocking and whatnot. So if one traffic class gets paused, then other traffic classes can still continue operating. I guess one thing I forgot to put down on the hardware side is we may need to have some sort of mapping between queues and priority levels on TX, and between the packets and priority levels on RX. Actually, I'm not even sure necessarily if we need to do PFC on RX or not. I think under certain circumstances that might be useful, but I think PFC actually sending the pause frames may be more reserved for switches. But I know at least on TX we need that. So I'm not sure if anybody else has done any work with PFC, knows anything more. If you have questions about that, it would be nice to be able to bounce these off some people. And then on the software side, obviously, there's going to be some level of driver support. I'm not sure if this is mainly in terms of configuration or a few other things. I think we need to take a look at some existing NIC drivers to see how this is usually implemented. And then there's some outstanding questions, right? So how to map the RX traffic to priority levels, and is it necessary? Are we looking at, does it make sense to just look at existing fields? Like if there's a VLAN tag, I think there's a priority field associated with that. For normal IP packets, I think there's a DSCP field, which can be mapped under the priority level. And then also how to efficiently handle multiple traffic classes in hardware. Are there any techniques for that I'm not aware of? And then also what needs to be done in the driver. So I'm not sure if anybody on here knows more about PFC. I know Bob at Cisco, you guys probably know more things about PFC, even if you don't personally. I'm not sure if you have any contacts or anybody we might be able to ask about that. I don't know. That's kind of an open question. It would be if there's any resources that we can draw off of to make sure we get this implementation right. That would be great. Anyway, that about rounds it out for PFC at this point. Hoping to work on that over the near future. I'm not sure how long it'll take to get all of this stuff operational, but yeah, that's PFC. The next thing that I've been working on over the past couple of weeks is the EXI virtual FIFO functionality. And the idea behind this is to provide the capability for packet buffering in DRAM, where you can store relatively large amount of data, megabytes to gigabytes if you want. The idea is to store both the packet data as well as the sideband data, so TID, TDES, TUser, that sort of thing, as well as the framing information, TKeep, TLAST, all of that. The intent is to support operation at 100 gigabits per second with all packet sizes, so you can basically take line rate 100 gig Ethernet, dump it into DRAM, pull it back out. For some of the research stuff that we're doing, looks like we'll have to do that 100 gig, maybe even 200 gig across multiple ports. The main bottleneck in this case is memory bandwidth. So we need a somewhat efficient coding scheme for encoding the framing and sideband data. such that all this can be written out into DRAM efficiently and then recreated on the other side. So for 100 gig, we're probably going to need 2 channels of DDR4 2400 and several HBM ports, hopefully 2, but it's looking like we might not get quite enough bandwidth there. So we may need to go to 3 or 4. 3 could be problematic due to just not being a nice power of 2. 4 should definitely be doable, but that's a fair number of ports. So the status on this is that I have the core portion of the FIFO more or less working, and I'm testing that in the hardware. And I have some bandwidth results over the next couple of slides. And the encode decode logic is to do. So I got to sit down and turn the crank on that. But back of the envelope calculations show that it should work without too much difficulty. Especially if we're going to be going to like 4 HBM ports where we have more bandwidth to play with. That should be fine. So what I've done now that I have kind of the core FIFO working is I've gone ahead and dropped it into Corundum basically as part of the DMA benchmark application. So we're just poking at the memory interfaces just as a sanity check to make sure they work, and also to figure out what kind of bandwidth we can get. So this is testing again just the core portion of the FIFO, so it doesn't encode any of the sideband data or anything. It's just the full width data, and no encoding, no framing, no tuser, tlast, tkeep, tid, tdest, any of that stuff. At least for now. The next step will be to add the encoding and make sure that works. So the data generation and checking is done in the PCIe clock domain at 250 megahertz. So at 512 bits, that's limited to 128 gigabits per second, and at 256 bits, that's limited to 64 gigabits per second. That's just the data width times the clock speed. I did need to play around with the DDR MIG configuration a little bit to get this to work at the full bandwidth. The Xilinx seems to recommend using row column bank interleave mapping with auto precharge enabled. I'm not sure exactly why. I guess this has to do with how AXI connected stuff normally operates. They recommend that when you have the AXI interface enabled. I can't remember if it pulls it up by default when you generate the MIG, or if that's just recommended in the documentation. But I wasn't getting very good bandwidth results with that. I had to switch to row column bank with auto precharge disabled, and then things were much closer to my back of the envelope calculations for what it should be. So the testing that I did consisted of basically 4 parts. The first thing I did is I wrote basically 1 million words into the FIFO, and then I simultaneously read and write 1 million words. So I start with 1 million words in the FIFO, I end with 1 million words in the FIFO, and then I read 1 million words with the FIFO empty, and then I do the simultaneous read and write again. So each one of these, I will compute the bandwidth, by counting clock cycles in the PCIe clock domain, and then I know how much data was transferred. So from that, you can compute the bandwidth. So this is what the results look like. I tested it on 3 different boards. So the first one uses DDR4 2666. The second one uses DDR4 2400. The third one uses HBM. So on the first board with DDR4 2666, we get basically we hit the data generation rate limit pretty much for reads and writes. 128 gigabits per second for reads, 124 gigabits per second for writes. If you do reading and writing concurrently without the offset, so basically starting with the FIFO empty, you get about 76.6 gigabits per second. If you do reading and writing with an offset, so this is starting with a bunch of data in the FIFO and ending with a bunch of data in the FIFO, we get about 73.6 gigabits per second. So it slows down a little bit when you do that. And then for DDR4 2400, the same test results in 69.9 gigabits per second for the read-write test and 66.4 for the read-write with offset test. So worst case here, so far 66.4, 2 of those gives you about 132 gigabits per second, which should be sufficient for 100 gig Ethernet traffic with some additional overhead for encoding and whatnot. So, that works pretty comfortably. For HBM2, This one has the, narrower internal interface at 256 bits instead of 512. Let's see, but it runs at 450 megahertz, so that changes the bandwidth a bit. For read and write separately, we're hitting, the full bandwidth limit of 64 gigabits per second. If we run the read plus write test and both the read plus write with offset, we get 49 gigabits per second, which two of those is not enough for 100 gigabits per second. Ethernet, we're going to need, probably 3 or 4 channels to make that work. And with 4 channels, we're well over 150 gigabits per second, close to 200 gigabits per second. So that should be just fine. The other thing to keep in mind is on the Stratix 10 devices, they play around a lot more with the HBM clock frequencies. So I took a look at the data sheets for both UltraScale Plus and for Stratix 10. For UltraScale Plus, they run at 900 megahertz, which corresponds to a 450 megahertz AXI clock for everything except speed grade. Hang on, it's for everything except the slowest speed grade, which I think for Xilinx, yeah, speed grade 1. The speed grades are reversed between Xilinx and Intel. For Xilinx, speed grade 1 is the slowest. For Intel, speed grade 1 is the fastest. just to be confusing. So yeah, for speed grade 1 on the UltraScale Plus devices, they run at 800 megahertz, which is 400 megahertz on the AXI interface. For Intel, it's a little different. On their speed grade 1, which is the fastest, they run at a gigahertz, so that's 500 megahertz AXI. The Dash 2 is 800 megahertz or 400 megahertz on the AXI, and then the Dash 3, the slowest one, is 600 megahertz or 300 megahertz on the AXI. I'm not sure why they drop off that quickly. Xilinx ones, they're basically all the same. Anyway, so if you're on a, Stratix 10-2, that's 400 megahertz, which is going to be, a fair bit slower than on the Xilinx devices at 450 megahertz. So that'll go down from 49 to, I don't know, 45, 44, something like that, I think. My mental math is working today. I think it's something like that. So yeah, that puts it even further away from what you need at 100 gigabits per second with just 2 channels. So anyway, the gist of this is that the results are looking pretty good at this point. Everything seems to be working. I just need to add the encoding on top of it, and then we should be able and clean up a couple of other things. And then I should be able to roll this into the Verilog AXI code, and then it'll be available for applications. And I'll also add it to the DMA benchmark design, so we can test this across all the boards in a pretty straightforward manner. Let's see. So that rounds out the AXI virtual FIFO stuff. The DMA benchmark application, just a quick update on that. I've gone ahead and added that for all the boards. Actually, maybe not all the boards. I think most of the boards. That's with a few exceptions. And then we'll be adding the DRAM test to that. And the idea behind this is the DMA benchmark application is a relatively useful kind of test design that we can load on a board to make sure that everything is working correctly. So by extending this to support using the virtual FIFO to test the DDR and HBM channels, that's going to make it a more useful component to make sure that all of the interfaces and whatnot are working and that the designs are building correctly on all the boards and whatnot. So this is going to be useful for a number of different purposes. But yeah, I'm only adding this to one variant per board. So if a board has like, a 100 gig version and a 25 gig version, I'm only going to add the DMA benchmark for the 100 gig version. So just to reduce the number of designs that get built and the number of files in the repository and whatnot. So yeah, that's that. That should be live in the main repository now, along with all of the other fixes and whatnot that I've talked about recently. I think I pushed that up like last week sometime. Because I have been working on a separate development repo. I think we discussed that on the last at the last meeting. Anyway, so that's that. The DRAM integration. Now that I've been working on the virtual FIFO and actually testing the DRAM interface, I haven't had to make too many changes to it because right now it's pretty much just the pass through. I did find a few issues in how the HBM integration was done, so I went ahead and made a couple of modifications to that and made a few fixes. But there hasn't really been anything else done in terms of the core logic integration in terms of adding connections to the DMA subsystem or anything like that. That's still all to do at this point. The one thing that I am going to be adding pretty soon is sort of a placeholder module that connects or that sits between the DRAM controllers and the core logic application section and whatnot. Main reason for putting this module in now is for simulation, so that'll give me points that I can connect to from CocoaTB for simulating the memory controllers. But eventually this module will also serve to hold some of these infrastructure components. So we're going to have some AXI switch components and a few other things that need to sit somewhere inside the design for connecting the core data path components, the DMA engine, and the PCI Express bar and whatnot to the DRAM, and that's how that'll be done. As well as I'm planning on supporting potentially a couple of different effectively clocking modes for the DRAM in terms of where clock domain crossing is done. So if you want everything running in the same clock domain in the application section, then we can implement that inside of this DRAM interface module. So that's about. I don't have much more to say about this at the moment, but that's going to be going. That placeholder module basically is going to be going into the repository, hopefully over the next couple of days, and then we can continue building on top of that. Let's see. And then we have the RAM bar. Once we have that infrastructure in place, then we can connect it up, hopefully pretty easily to the DMA subsystem and to a new PCI Express bar for accessing memory. So that's to do once we have the switching infrastructure in place and CDC infrastructure in place. Let's see, and then all of this, the remainder of the slides that I have here are basically carryover from previous stuff that I was working on. So the batch completion write support. That's on hold for now, but we were making some progress on that a while ago. I think that about rounds out all of the new stuff that I wanted to discuss. So let me take this back to, the other thing I wanted to mention briefly. I'm starting to take a look again at the management software and kind of the infrastructure that's necessary for this to work. And I'm hoping to get the kind of JTAG interface stuff integrated in across the board designs relatively soon. So the idea behind this is to be able to use the Xilinx, I guess the XVC, maybe? No. They have a PCI Express extended capability that will sit alongside of their PCI Express hard IP core that's used for interfacing with on-device JTAG chain. So the idea is that on all the UltraScale Plus designs, we can go ahead and drop that in, and then that can be used to talk to either the management software inside of Corundum itself, or it can be passed into the application section if you want to put RISC-V cores or something else with a JTAG interface inside of the application section, and then you can access this via PCIe. And eventually, I also want to do something more vendor independent, but potentially that's going to require more customized software like modified OpenOCD or something like that to talk to. So if we start out with the Xilinx's somewhat proprietary solution, then we can make sure that that the JTAG chain works and whatnot, and we can get cores operational before we start doing something more customized. So hoping to get that in there relatively soon. So, because I know there's at least one person who's already using that. So if we can get that set up across all the boards upstream, then that'll be a nice feature. Let's see. The 10D, 25D switching stuff. Okay, and then the to-do list. So let's see, where does that leave us here? Oh, I guess one thing I should mention is the self-contained checksum offloading. That's been on this for a while. This one, I'm not sure if I want to do this necessarily. This might be a something to discuss. Obviously, having self-contained checksum offloading is useful if you're, generating TCP, UDP traffic inside of the application section. But in terms of offloading checksums from the operating system, at least from looking at some of the comments in the Linux kernel source code, they seem to imply that they don't really like the totally, self-contained IP aware checksum offloading. They seem to prefer just getting, at least in transmit, if you provide, an offset and a location of a checksum to fill in, and on RX, just having a checksum of the entire Ethernet payload, and then backing out the proper fields. That ends up being more flexible because it's, it's not dependent on the hardware being aware of the specific protocol that you're trying to implement. So I'm leaning towards, okay, maybe we should not bother with the self-contained checksum offloading, which is actually going to be aware of IP versus TCP versus whatever, and implement something and just keep the current checksum offloading. So not 100% sure about that. I'm not sure if people have opinions on that. But I think the main thing with the we're going to cut a a stable release is to finish off the management software and get that integrated, and then do some additional work on the shared interface data path and internal flow control and whatnot. And if we get that finished up, then I think we'll probably be good to go ahead and cut stable version releases, which I think that there's been a number of people asking about that. So that'll be good. We'll be in a good position to do that. All right, so that about rounds out in terms of the status related updates. I can now open things up to discussion. If anybody other than MLE has any questions or comments, fire away. And then once that's out of the way, then we can turn the floor over to the folks at MLE. So. I'm not sure if Bob is back at the moment, but I posed a question to Bob about PFC. Maybe you were busy or something. We were hoping to have some people to, bounce PFC implementation ideas off of. Maybe you're not familiar with it, but maybe other people at Cisco who are more familiar with PFC and its requirements and usual implementation and whatnot.
Yeah, no, I haven't looked at it. Yeah, so I'll take a look at it, see if I can find someone.
Okay, because that would be cool, just to make sure that that we're doing things in a standards compliant way, such that it works with existing devices. Because I know switches tend to support that, and Cisco certainly makes a lot of those.
Right. I mean, some of our ultra low latency portfolio runs EXOS, so it has a different set of specs, right? Compliance.
Right.
But definitely the NXOS switches on the mainstream. Yeah, we take a look at that.
Right. Oh, I guess the other thing I should mention is that I did that TCXO switchover for the PTP clock for which boards did I do that on? I think just the X25 and the X100. Yeah. Still, it's funny. We're all still using the Exablaze naming for that, just because the Cisco naming is such a mouthful.
It's almost universal. Our customers, they don't like the new names. Yeah. Anyway.
The other thing I was actually trying to figure out with the new naming, is it the -S and the -Q, or is it the -X2 and -X8 or whatever it is? Because the board, let's see, I think I have one of these. What did I? The board has a slightly different naming printed on it, right? This
the part number, that's like the orderable part.
P-8X.
Yeah.
I don't know if you can see that. So I was a little bit perplexed by that.
the NXN, that that's the short name is like, the abbreviated name is K3P-S and K3P-Q. The actual orderable part number is with the 8X or the 2X, right? So that's
Interesting.
like,
All right.
so that's
Just to make things
that's
confusing.
yeah, all our systems, if you need to order the part, it goes by that longer one, right? The NXN K3 or K3P, and then the 8X or 2X.
Right. Gotcha. Okay.
And then there's ones for memory that get tacked on when you have because we have ones
right,
that's
yeah.
optional memory, 4 gig, 9 gig, right? Yeah. So that's the longer part name. So how it's orderable.
Yeah. Okay. I guess a quick note on the memory. I have the memory interface operational on the X100 card, but my X25 doesn't have any DRAM installed. So I don't have a way of testing that unless you guys have one of those with the DRAM installed that you could send me. So
I'll see what I
not
can
a super
find
high
out.
priority, but
Yeah, make a note of that. All right.
yeah, because I mean, at the time you sent those to me, I'm like, I'm not doing anything with the DRAM, so whatever. You can just send me one that doesn't have any. But now that
Well,
we're starting to bring that up, I
Yeah,
guess the other thing about that is I think the memory interface is only like 32 bits wide or something. It's the bandwidth is lower than on some of the other cards, right?
Yeah.
Like the
V9P and the V5P, I think.
right.
Yeah, I'll see what I can do there. I don't know if it's high priority, but we don't allow, maybe I could get you the we don't normally allow, because of testing and shipping, to do it in the field, to add it into the field, right? And how it's constructed.
I don't think I have the capability to do that. I can certainly send you the cards that I have here if you guys want to rework it and put the RAM on there or something. But
Probably
it looks like there's several parts that would need to go on there besides the RAM too. It's missing. I popped the heatsink off not long ago just to take a look at something on there. I guess I was taking a look at the oscillators to double check what was on there. But it's missing several things. I guess an oscillator and I think some power supply components. Because the DRAM requires a couple extra power supply voltages. So
yeah,
it makes
we
sense
don't
that if
have
you
an
don't put the
upgrade.
RAM on, you leave all that stuff off. So
Yeah, we don't have an upgrade kit or anything like that in the field.
right. Yeah. No, I figured, if you guys have one with RAM installed and you wanted to send me that so I can make sure that I can get that working and put that in the repo and whatnot, then cool. But
Yeah.
but not a high priority. I mean, if
Right.
you got somebody asking about it, then I could certainly do that.
Right.
Otherwise,
I think that's probably what'll drive it, right? Is if we have some
Right.
interest, someone wanting to use that. It's currently. I had a quick question. This is probably not. This is Pixie
sure,
boot.
fire away.
I don't think.
Oh, PXE boot.
Yeah, Pixie boot or any sort of boot ROM. I don't think Corundum supports it. Some of our NICs
Corundum doesn't have that. Part of the reason is that I have no idea how you even build something like that. So I was taking a look at kind of how the ROM bar worked on the PCI Express side. So I don't think it would be all that hard to create the ROM bar where one of those ROMs would be accessible. But the other component is actually creating the binary that you put in there.
Right, the boot ROM. But there's plenty of open source. Most of them use the iPixie. I think it's
Right. Yeah, I actually stumbled across that
iPixie
recently. I don't know if it was GPXE or IPXE,
yeah, they use,
something
there's
like
that one too.
Right. Yeah. And
So-
I guess that's probably most of it. And you probably have to basically put the NIC driver in there or a stripped down version of the driver, something like that. So
yeah,
that's not something that I've looked into. And speaking of boot stuff, I did actually pick up a proper rack mount server for testing. This is an R7920, which I think is very similar to an R740. And it seems very finicky about detecting some of the FPGA boards, and I'm not sure exactly why that is. It might have something to do with the board's taking a while for the design to load on the FPGA and for the link to become operational. So if we want to do anything in boot time, we're probably going to have to get that sorted out one way or the other. And that's, I think on the Intel devices, that's a little bit easier because of how the PCI Express hard IP core is wired up and how has dedicated connections to the transceivers. So basically you can set up the bit stream so it configures all of the IO stuff first and actually brings up the PCI Express core and then does the rest of it. And you don't need to do anything weird for that. On the Xilinx side, you have to use like the tandem configuration. And from looking at that, it seems like there are some pretty significant downsides and complexities introduced by going that route. And that seems to be the only route for actually speeding up the boot time on this, right? Because you basically have to do a partial reconfiguration flow where the initial bit stream loads the IO stuff and brings up the PCIe, and then you basically load a user design into that. And the problem is that the tandem configuration by default totally takes over control of the pins to the flash chip. So unless your frickin' board design connects those to multiple pins, including not just the dedicated configuration pins, once you use tandem, then you can't reflash it via PCIe, which is totally stupid, but that's just how that's wired up apparently. So I don't understand exactly why they did it that way, or why. I mean, I guess they probably did it that way because it was convenient. But what I don't understand is why they don't have even any kind of pass through for those pins. So once the design is loaded, then you can still talk to the flash. But so yeah, I'm not sure if it's possible to use tandem or if we would have to like roll our own version of tandem or something. I don't know. Because doing something like that might be necessary to actually get this thing to boot up properly in some machines. And then if you want to do PXE on top of that, you probably could. I guess the other thing is if you wanted to do something like a boot ROM, presumably you wouldn't want to put the actual ROM in the HDL code, but you could do some kind of an indirect thing where, a read comes in for the ROM, then you direct that to a certain part of the configuration flash. Because I don't think that has to be very fast, which obviously would also complicate the flash format a little bit, because now you don't just have the FPGA configuration bit stream, you'd also have the PXE ROM in there somewhere. So
yeah,
lots of stuff to think about there with regards to that.
Right. I just like we've had customers in our regular ask about Pixie Boot, and it's supported on some of our FPGA based NICs, the X10 and the X40, but other ones don't, right? And I'm trying to get.
Well, it seems like if it's supported on some, it shouldn't be hard to make it work on all of them, right? Because I think your interface is probably the same or very similar across all of them. So it's just a matter of getting that ROM in there.
Yes, and yeah, so we are working on that, or at least we have a little project. That's for our base card, though, the X25 and the X100.
Right.
But I was just curious if there was anything I could glean from Corundum to help with that effort. And
yeah, that's not something that we've really looked into, because on all of the machines that we're using, if we're net booting, we're going to boot off of the integrated NIC.
Right.
Off of a gigabit management network sort of thing. It's like actually one of the test beds that we have set up at UCSD, that the whole thing is net booted, but it's not net booted via the FPGAs. It's net booted via the built-in gigabit NICs. Just because, well, we had that test bed set up before Corundum, worked. So, yeah. But yeah, I can definitely see why people might want to use NetBoot if they just have the one NIC in the machine. Although the flip side, then it makes firmware updates a lot more risky. If the firmware update doesn't work well, then your machine is totally hosed. So
yeah, there's workarounds, but yeah, it's ugly. Yeah, but definitely we do have customers doing that, right? They're wanting to do that. Only putting certain cards in certain slots and only so many slots, and using the management ports separate for entirely different network. And so kind of the
Mhm.
build network is just one network and runs over the 10G and to re-image systems. Plus they, some of those are only 1G on the motherboard or on the, the system. So yeah, they like to have flash imaging, down to the system and through the 10G network, right? Provisioning network. Yeah. So anyway.
Right. Yeah. That definitely makes a lot of sense. I can see the use case. I just, my focus is on getting
Yeah.
the data path working.
I get it.
So,
I get it.
if somebody wants to help out with that, I'd be like, hey, great. I'll I can help on the PCIe side and and try to get the the ROM actually visible somehow. But in terms of some of the secondary concerns, in terms of getting the interface link up. Well, I guess that's almost somewhat tangential, because if the card doesn't bring up link quick enough, then it might not enumerate at all. So we might need to cross that bridge anyway.
Right.
It would be nice if this is like a PCI Express standard thing where there's a certain time window between when power is applied and when the software needs to be able to talk to the card. But it would be nice if there was like some option in BIOS to say, to hell with that. Wait a second. I mean, it's not that much longer, right? 100 milliseconds is pretty quick when you're talking about an FPGA loading its configuration. But yeah. It's like a lot of these machines support like the Alveo boards and whatnot. They're set up for this kind of accelerator device, but I haven't seen an option in BIOS yet for just hold on a second. Give these cards some time before you try to talk to them.
Yeah, a delay.
Unless, of course, there's something else going on, and that's not actually the problem. I just know that some cards are very finicky in this machine. I haven't seen that in any of the desktop machines that I've tested in. So, and the funny thing is, servers take so darn long to boot in the first place. It's like, what's the deal?
What's a few more seconds? Yeah, absolutely.
Yeah, 100 milliseconds versus 1 second. Nobody's gonna notice. Anyway, all right. All right, then I guess the other thing that we brought up with that discussion on the TCXOs is just on the clocking on the various cards, because on, I think, the X10, X25, and X100 all use basically fixed oscillators. But some of I think you're saying some of the higher end cards with the Vertex devices that you guys make, those use the adjustable oscillators, right? The SI570s or
They do, but
PLL chips of some sort.
you have the SI570, the V5P, the V9P.
Right.
And
Yeah. So that's why I went ahead and made that change for those two cards, because for boards that have those adjustable oscillators on the Ethernet transmit role, we can potentially use that for like synchy applications and actually slew the oscillator for various synchronization reasons. So yeah, in that particular case, it might make sense to do something else for the PTP reference clock if you want something more stable. So I think you mentioned that briefly, like we could potentially use the higher stability TCXO to discipline the SI570, use a soft core or something to do a PLL to bring those into alignment instead of, using the 10 megahertz directly for the PTP clock for better holdover. Because I think that'll be more flexible long term. And I actually just had somebody recently ask me about White Rabbit in Corundum, and if there was any possibility of doing that. So it definitely looks like there are use cases for synchy White Rabbit type stuff in Corundum, where you have a much higher precision time synchronization that you can get with PTP, which would require this kind of functionality. So the card supports it, and we can put the pieces together to make it work. Then that's a pretty powerful thing to be able to do. So it's unfortunate that you can't do it on the the X25 and the X10, but you probably save a few bucks on putting a fixed oscillator in there.
yeah, it's
Anyway, do you have any other questions or?
No, that's all I had. Thank you.
All right, let's see. I'm not sure if Antonio wants to say anything. So Antonio is the grad student who expressed some interest in using PFC. I'm not sure if you want to introduce yourself, or I don't want to put you on the spot either. We can't hear anything, Antonio, if you wanted to say something. Antonio, I noticed you're off mute, but I can't hear anything, so I'm not sure if you're double muted or need to adjust your microphone or something. This is usually
Hi.
Oh, there we go.
I was double muted.
It's usually Joachim who has that problem.
Yeah, I'm with a headset and I'm not used to it. Well, nothing really to say, just to present myself. As Alex said, I'm a student from the University of Castilla-La Mancha in Spain. And I'm going to work with PFC, so I would like to help and collaborate in developing that protocol. And just I have quite a bit to learn, so I hope to do my best. And any help is welcome.
All right. Well, thank you very much, Antonio. I'm definitely going to do what I can to help Antonio with the implementation. If anyone else has any comments or useful information about PFC that we can pass along, that would be great. And I think I started a discussion on the Zulip under the ingress egress channel about PFC.
Yeah,
so if anyone wants to chime in about that, that would be great.
Thanks.
Yeah, and also Antonio, we got Bob here at Cisco, who it sounds like he doesn't know a whole lot about PFC himself, but they definitely have people that know things about PFC at Cisco. So if we have any detailed technical questions, we can potentially loop somebody in there.
Yeah, that would be great.
Yeah, that's good. Yeah, just feel free to loop me in and I'll find the right people.
Thanks.
Might as well use all of the available resources, right?
Yeah.
All right. All right. Well, nice to hear from you, Antonio. Now, at this point, if there aren't any other questions or comments, then we can turn the floor over to the folks from MLE. Does anybody else have any questions or comments? Going once, going twice? Nope. All right. Well, Ulrich, Joachim, take it away. Assuming you guys,
I think I just had a question with respect to the FIFO tests, the RAM FIFO tests. So are you just linearly, basically in the RAM, are you just linearly writing words, or is the exercise larger than this?
Yeah, the exercises are larger than that.
Okay.
The code, it attempts to pack complete bursts together before issuing a read or a write. And there's a timeout mechanism. I think it'll wait up to 256 clock cycles. If it doesn't have a full burst, then it'll issue the operation anyway. And it tries to get out a number of read requests. That's another problem that I had, is not issuing enough read requests at once, and then that was causing issues with the arbitration logic in the MIGs, and I wasn't getting very good throughput. So yeah, it tries to batch for both the reads and the writes. And then, at least as of right now, it's relying on the memory controller to arbitrate between the reads and the writes. So you got to pick the right arbitration setting. Otherwise things don't work very well. I was thinking TDM might work great, but no, TDM works terribly because of bus turnarounds. You want to batch a bunch of reads and then a bunch of writes to amortize the time it takes to turn around the DDR interface. So yeah, once you get the right settings, it seems to work pretty well.
Yeah, that makes sense. Yeah, okay.
Yeah, and I guess part of the FIFO code as well is providing some parameters so you can kind of tune those burst size and FIFO sizes internally to kind of tune the performance. So depending on what sort of memory interface you're using, you might need to make some adjustments to that. So there are some knobs available for that. And the batching is done on both the for both the reads and for the writes. And I guess one thing to mention about the batching is that it aligns all of the bursts in the address space. So if it has enough for a full write burst, but it crosses a burst size boundary, then it'll actually issue 2 bursts instead of 1. And that just simplifies the logic a bit, and it shouldn't make any difference if you're moving large amounts of data. At least that's the current implementation. If we have to revisit that, then we have to revisit that. But the other thing is, getting stuff to work at 450 megahertz for HBM, you kind of have to keep things simple.
Yes.
And yeah, it's definitely a very incremental process. You get it working at 300 megahertz for the regular DDR controller, and then you move to HBM, and it's like, geez, we're going from 3 nanoseconds to 2.2. It's an incremental process to go through and hammer on all of the timing paths and get stuff to work. So, but yeah, it did close timing. I guess one thing I should also mention is that right now I'm not actually doing anything with the read data. I have some PRBS pattern generators on to generate the write data. So it's not all zeros or all ones or something like that. But on the read side, I'm not currently checking that. So that's one thing that I need to do. But so I'm not sure if everything is working correctly from the standpoint of the actual data, but throughput wise, we are obviously looking at all of the AXI signals and whatnot. So the test is not quite complete yet. Right now, it's just kind of a proof of life that things are working, and then also to get an idea of what the throughput looks like to inform the design of the encoding and decoding components. But one thing I will note is that the bandwidth is about 85% of what the theoretical max should be based on back of the envelope calculations. So I think that's pretty promising. And then I guess the Xilinx documentation for the MIG says that a mixed burst read write workload should get about 90% of the it should be about 90% efficient in terms of the interface utilization. And when we do the test with the FIFO empty, then we're like spot on 90% of what the expected bandwidth would be of the of the interface bandwidth. But then we lose a couple of percent when the FIFO has data in it. So I'm not sure exactly why that is. That may just have something to do with how the DDR chips themselves work. Like if you write to a page and then immediately read from it, that might be slightly higher performance than reading and writing to pages in different parts of memory. Not sure about that.
Yeah, so that's what I wanted to come to actually, because we did some implementations where we used RAM for large buffers, but yeah, one side was kind of FIFO, so it was like linearly written into the RAM, but then it was arbitrarily accessed out of the RAM, because the other side was like a DMA engine, and it could choose when to read which block actually, and it really, if you have like little blocks or chunks of memory that you access, it's really bad, really bad. So the larger the blocks get, the better it is. So it might make just sense to aggregate quite some chunks until reading or writing them.
Right. Yeah. That definitely makes sense here, and that's kind of how I have it set up. So if the chunks are coming in quickly, then they are aggregated. If they're coming in slowly, then it doesn't matter because they're
right.
slow.
That's right. Yeah. Exactly.
So you can have a
You
pretty
just-
short timeout on that. Yeah.
Yeah. Okay. Yeah, that makes sense.
Yeah. And then all the code for this is going to end up in the various repositories soon. So if you're interested in, borrowing some of it for, whatever project, it'll be available. So,
Cool. Yeah. Yeah, you
all
could
right. So
do
anything
interesting
new
things with it.
on what?
You could do interesting things with it, like
Yeah,
generating latency on data streams.
Right. Yeah. Oh, the other thing that I don't know if I mentioned this in the slides here, but the way I'm putting the virtual FIFO together is specifically to support the use case where you need a lot of bandwidth. So I know a lot of the existing AXI virtual FIFOs, they all run in one clock domain, which, makes sense. But I was thinking about it and it's like, okay, we're going to need to have input and output FIFOs on this thing anyway in order to do the aggregation. So why don't we just make those FIFOs asynchronous, and then our kind of core FIFO can actually support moving stuff between different clock domains. So you can feed data in from one clock domain, and then you already have the asynchronous FIFO built into this. You don't need to drop down a separate one. That'll transfer it into the AXI clock domain, and then you can cross it back. And this works. And then what we can do is combine, multiple of these. So for 100 gig Ethernet, you got to use, 2 different memory controller channels, and those are each going to be using their own clocks probably. So you can come from, one starting clock, cross into both AXI channels, right, where the data gets stored and then read back out, and then cross back into potentially a different clock domain. So just to make things, more flexible. Because I think in a lot of applications, at least like with Corundum, most of the data path all runs in the 250 megahertz PCIe clock domain. So, being able to support within the same FIFO module going into, 2 or 4 different, DDR MIG clocks and then crossing back, that definitely simplifies things. And also dealing with HBM, right? That's a 450 megahertz clock. Well, only the FIFO needs to run that fast. If you transfer the data from your data path over, a slower clock, then that eases the requirements on the data path potentially. So I'm trying to bake features into the FIFO, like that, which should make it easier to use. And then again, also supporting, arbitrary AXI stream transfers. So some of the other FIFOs that I've seen, it's just the data. They don't store any framing information, TLAS, tkeep, anything. So. All right. Is there anything else to discuss from the MLE side of things with respect to Corundum, or have you guys mainly been busy with other things?
Yeah, basically, yeah, mainly with other things. Perhaps a question for the future, I would say. We recently looked through past slides you made regarding performance tests, and
Yeah.
we saw that you usually test, of course, for the 100 gig case using your big iron machines.
Right.
And we're wondering, or I'm wondering, kind of as a question, do you have any other numbers where you would test for other criteria, for example 10G, for example sweeps over packet sizes? Do you have such numbers available for certain boards? Or
Well,
wasn't
not at
that
this time, but we could
criteria
certainly
in the
do
past?
some benchmarking and put something together. If you have something specific that that you want to test, we could potentially do something along those lines. I mean, the whole benchmarking thing is relatively is a relatively recent addition to Corundum. So I have a set of scripts that I use for running those. But those are kind of like sanity check level.
Yeah.
If we want some, kind of more full characterization, I mean, we could probably just add some more stuff to those benchmark scripts. In fact, that's probably the simplest thing to do if there's some tests that we want to try. We can certainly add that to those benchmark scripts, and then I can try to run that, as part of the process of testing stuff. But I guess it also seems like you're asking about running this thing on lower end machines too, or
Yeah. So yeah, I mean, in the end, it's also always a lot of work to perform tests on on a big number of criterias. That's why I'm would like to generally ask if you did something like that in the past and have numbers, possibly have numbers available.
well, not really. Yeah, I don't really have historical numbers, that would be really of much use, because there's been a lot of internal changes to Corundum and whatnot. So if we had numbers from months ago, what's the utility if the design has changed a lot? Which is why I'm thinking, if you are interested in something like that, I could certainly put a NIC in a lower end machine and do some testing with that. I mean, obviously you can't test with every possible machine, but at least the nice thing about Corundum is that it behaves basically the same across all the different boards. I mean, obviously there might be some differences between Xilinx and Intel, but all the Xilinx boards are going to behave the same. All the Intel boards are going to behave the same. So I could certainly put a couple of NICs in a lower end machine and do some testing. I have a couple extra, some of the older dev machines that I was testing with that are like 4th generation i7, something like that. So a few years old. I could certainly do some benchmarking with that if we can have a better idea of exactly what it would make sense to test. And feel free to submit pull requests against the test scripts themselves if you want to add whatever you want, and I'd be happy to run that stuff. So if you get the test that you like working on your end and it doesn't require a whole lot of esoteric utilities to run, great. We I can run it on my end, and having some more comprehensive tests would probably be useful anyway for sanity checking, right? Just to make sure that things are working across different packet sizes and whatnot. And
So
potentially some of the stuff can be automated, right? If it's just you run this one script and it runs all the tests,
it
wouldn't be hard to automate that.
Yeah, that's basically what we have done in these past weeks, mainly to automatically, more or less automatically test our Corundum based custom NIC.
Right.
And since we are kind of through now, or set up all the tests there need to be, we are basically looking at the performance now, the numbers which we get, and we see certain patterns which on the one hand touch our own custom functionality. That's one thing, but on the other hand, we see interesting effects without using our custom functionality, or our custom functionality is out of the picture in these cases. And one of the key points I would say is also the performance for small packet sizes, for small payloads.
Right, where you have a higher packet rate.
And
that's been one area of Corundum that I have not spent a whole lot of time optimizing. I've mainly been looking at just throughput, but yeah, definitely trying to look at packet rate at some point is going to make sense. Right now, with the way the DMA operations and whatnot are issued, I don't think it's very efficient. for, large numbers of packets and whatnot. So like once I get variable length descriptor support implemented, where we're actually able to read descriptors in blocks as opposed to one at a time, then I think some of those, it's going to make sense to spend more time looking at, higher packet rate operations, because now we'll actually have potentially the ability to tune some of that and figure out, what to do to improve the performance. As of right now, well, the performance is not great because we're reading every single descriptor in its own, DMA request, which is not great.
Yeah. And on the software side, there's we already had this in the past, this topic, the page pool topic, buffer recycling, these things. And yeah, we recently considered that again, did a quick test, and yeah, unfortunately not so promising results. We thought that this page recycling using the page pool should have more effect, but for some reason it does not have that effect. So the current assumption is that our experimental patch to use the page pool is not complete or not correct. Which in turn is, of course, still based on what Girai started.
Right.
So
what just wondering, with the page pool setup that you implemented, are you also handling the DMA mapping? Like, are you leaving things mapped, or are you unmapping and remapping when you're putting stuff back in the pool? Because I think part of the this is definitely something to think about, but reducing the number of map unmap calls, I think, is going to be a pretty significant overhead savings. So that's one of the ideas of the page pool, is if the you just leave the page mapped until you're totally done with it, and then you unmap it. I think that I need to take a look at what other drivers are doing. It's been a while since I've looked at this, and the driver side for me is a little bit more fuzzy than the hardware. So the other thing with page pools, it sounded like you guys might not be able to use that because you're running on an older version of Linux. But I guess the idea is if you get a performance benefit, then you might be able to, backport some of that or implement something similar. I guess the other component is
convince the requirements to say, okay, we need a newer kernel.
They go to the customer and say, hey, if you change the requirement to this, then we'll give you better performance. Basically.
On the other hand, completely also a very strange finding where we didn't put any time into this, just observed it again, that newer kernels seem to be kind of slower in the same configuration, same setup, same hardware setup.
Interesting.
And that for some reason, this older kernel we have to use currently seems to be the fastest one. We still don't have an explanation for that, and it's also the main point is, when looking at this Intel NIC we're using here, the X710 card. Where also the difference is substantial. For example, for small block size, can't remember, I'd say 402 or 200 bytes. It's around a gigabit less bandwidth, which is coming out of an iPerf test in this case.
So this is not looking at Corundum. This is just looking at the Intel NIC. Yeah, interesting.
Yeah.
I mean, to some extent, that's not surprising, because they're probably adding, new features to the networking stack and whatnot with the newer versions of the kernel. And, new features doesn't necessarily mean better performance.
Yeah, so
Interesting.
lots of stuff to do for next year, I guess.
Right. Well, I mean, some of this stuff is potentially things you could ask on, the Linux kernel development lists and whatnot, and say, hey, we're comparing kernel version X and kernel version Y, and we're seeing a big difference in performance. Any sense in where this could be coming from?
Yeah.
Is there a configuration option that we need to flip or something, or is this just, inherent to, newer code with more features run slower,
Mm.
Because if this is decoupled from Corundum, that's potentially something that could be asked about, and maybe somebody has a useful answer to that. I don't know.
Yeah, we'll do that.
I don't know. Hey, another thing you could do is you get your hands on some Cisco NICs and try it with those, and then we could ask Bob.
Nah, I don't think we have Cisco NICs. I've never seen those in the lab, at least.
Oh, we can get you some.
Yeah. So Uli, I guess we need to tell a shipping address here.
Yeah, always happy to receive hardware.
Well, the Cisco
Yep.
NICs, are they actually with Cisco chips on there, or do you guys like rebrand Intel NICs and other manufacturers? Just out of curiosity, or do you know?
We have both. So yeah, we do the
Okay.
VIC you're talking about, like the ASIC? No,
Yeah, I'm not sure what
We have the
exactly
VIC.
Cisco makes
Well,
in
the
terms of
VICs
NICs, but
the VICs only work in, but we do resell. We don't call them ours, but we do resell. Mellanox, whoever, right? But our NICs go in our UCS systems. Those are VICs, and those are our chip and our ASIC.
okay.
Yeah. And the ones that, like, if you're talking about load generation, like work with T-Rex, we support a number. T-Rex is our tool for load generation, millions of packets per second, right? To do heavy duty load testing, line rate sort of stuff. And those work on our VICs, but they do work on some other VICs, right? Our VICs. Our VICs are only certified right now in our machines, right? So your mileage would vary if you put those in another machine, and we wouldn't support it.
Right. Okay. Okay. Yeah. I mean, I've seen various in poking around on eBay. I've seen various kind of used Cisco NICs, and some of them look very similar to Intel NICs and whatnot. So I'm like, But some of them, yeah, definitely. I think the VICs, look much more custom. Some of them, I was even like, do those have an FPGA on there? Wouldn't be the main chip, but it might have something else on there. So
yeah, I don't have the full history, Alex. So
whenever I'm poking around on eBay, I'm always on the lookout for cards that have FPGAs. And you can never be 100% sure until you actually get the thing and pop the heatsink off. But I think on some of those cards, I saw stuff that looked like a Xilinx JTAG header or something. So I'm like, I'm guessing they probably don't use an FPGA on there, but that header is intriguing.
yeah. I mean, we've had ASIC based NICs for a while, but I don't know the history, so the full history anyway. So we might have had an FPGA based sometime.
Well, it's not unheard of to have like a FPGA or CPLD or something for, ancillary features. So
Sure. Well,
anyway, yeah.
Some companies like Solar Flare, they had a JTAG or they had an interface on there where you need the card's firmware's messed up and you need to program it. So send it back and can access things. So
right. Well, I mean, one, Solar Flare is now owned by Xilinx, and two, I know Solar Flare did make some cards that also have FPGAs on there. They're application on load or something cards, I think, where it's their ASIC and then some FPGAs. But
They did.
I've certainly seen those. I have not picked up one myself because my understanding is the FPGA is just kind of hanging out there somewhere. It's not really connected to anything aside from the, NIC ASIC directly. So from my use
Right.
case, it's not very interesting. But
No, the AOE, yeah, I don't think there were two versions of AOE, and I don't think you want to use either. of those. They had an ASIC in front of the FPGA, and yeah, and there was an Altera, slash, Intel FPGA.
right, yeah.
Yeah,
Yeah, no, I've
But,
definitely seen those cards kicking around on eBay. So
yeah, I don't think, although the early solar flare, like the 4000 series, those were FPGA in the 5000, but those are way old. Those, then
hmm,
I think even the 6000 might have been, but now 7000, 8000, and Xilinx just came out with one 3522 recently, so which is FPGA based and runs some of the solar flares. So that might be interesting to you, but that's pretty new.
right, yeah. I was actually asking them about one of their cards that they came out with more recently. I was yeah, I guess it was their SN 1022, I think, was the card I asked them about. Like, hey, since that card came out after they acquired Solar Flare, did they like put Solar Flare's RTL on there? But it sounds like that was actually kind of a more specialized implementation. But I think it was the Solar Flare guys that were working on it. So yeah, no, I haven't looked at their kind of smart NIC stuff recently, because some of that more specialized stuff, it seems like they're doing some more work to lock it down in various ways. So like, for example, I know they have a card that looked super promising with a Versal device on there. Their VCK 5000, I think. I'm like, wow, that looks pretty cool. We should get one of those and get Corundum running on it. But it looks like they have it locked down so you can only use the Xilinx reference design on there. That accesses the AI cores. So it's like, well, if we got that in, then it would just be a paperweight because we couldn't run Corundum on it. So good thing I never tried to get my hands on one. Anyway, I'm not sure how different some of their smart NIC offerings are. That's not something that I've looked into recently. I know they had like I think it was a U30, which is kind of a weird setup. I think it was like one of the, I'm not sure if it's a Solar Flare NIC or something. It's a NIC ASIC plus like an MPSoC, and then they bifurcated the PCI Express interface. So it's 2x8 on the edge. Kind of an odd setup. Anyway.
Yeah. No, I don't have any experience with it.
Yeah. Enough of a sidetrack there.
Yeah.
Anything else to discuss? I mean, I guess getting back on track. What were we talking about? I guess benchmarking with various various
benchmarking,
machines, various kernels, various NICs.
But-
yeah.
Yeah,
Okay.
we have to kind of I'd say start that next year or get into that and dig out more details and come up with explanation why is it behaving like the way we see it or why not. And yeah, I'd say we keep you posted what we come up with, and yeah, if you also are able to run tests, then given we provide test scripts, that would be great.
Right. Yeah, I guess one thing to mention about testing is that, if there's, we should just discuss that on Zulip, and if you guys want to, make modifications to the default Corundum test scripts or write new test scripts or something, then I'd be happy to look at integrating some of that stuff. So I can run the tests that you guys want to see in addition to the tests that I've been running. Because there's definitely all sorts of measurements that we could make. It's just, hey, can we do this in an automated way and run it across, all the boards? And yeah, so definitely something that I'm open to discussing and putting some time into if you want to help out with that, if you have some ideas. I mean, it sounds like that's something you've been working on, so I don't know if anything that you've done dovetails at all with the core Corundum logic and the test scripts and whatnot that I put together so far. But
No, we are not using the test scripts as is, but more or less we are doing kind of the same thing in a different environment. We are using PyTest for this automation, also including LabGrid. But
Oh, right, yeah, because you're
basically
running across your test bed setup.
yeah, we are doing the same thing, running iPerf to see how TCP behaves mainly in various scenarios in parallel, sequential. Also regarding our customization functionality to test that out. And we look at rates, we look at loss rates, packet losses, we look at certain other parameters. But iPerf is the basic test vehicle here. The only difference I'd say is that we're using iPerf 2 instead of 3, because we hoped also to do UDP testing. And in the past, I just remember, I don't know the details anymore, but in my mind, the UDP mode of iPerf 3 is kind of strange, and I never got it working correctly. And now it turns out
I've run into my own weird issues with iPerf. So yeah, that's surprising.
And now it turns out that even the UDP mode of iPerf 2 is somewhat strange.
Well, I mean, nothing wrong with using multiple tools and using the right tool for the job.
Right, yeah.
I don't know if you've looked at NetPerf at all.
We can say we use that regularly in other projects.
Okay, because I know NetPerf also does UDP, so that might be something to look into as well.
Yeah, I'm not sure. Uli would have to comment if you're using it in UDP mode, since the other project is TCP oriented too.
Yeah, we can do both. We just re-enabled using UDP recently. So that project is basically put together around a TCP full accelerator, and there is a NetPerf hardware FPGA based implementation sitting right next to it. So yeah, we know NetPerf, at least the 2.6 version, which is a little bit old, but yeah, works fine anyway. So that were performing pretty okay with UDP, at least from my memories.
Yeah, so we definitely have to look at potentially have to look at other tools here also regarding UDP. I mean, again, that's customer requirements, so we have to come up with numbers here, reasonable numbers, and it seems like iPerf 2 is just strange. Yeah, we simply don't get the rates we would like to see, not even with heavy modification of network stack parameters, kernel parameters here, socket sizes and so forth. And on the other hand, when using the in-kernel packet generator, which is based on UDP, also it has no problem at all generating line rate with a standard 10G NIC, or for that matter with the QNIC, at least with full-blown MTUs or standard MTUs 1500. And for some reason, I'm unable to tell iPerf 2 to do the same from user space.
Interesting. Well, so I guess one thing that I have noticed between iPerf 2 and iPerf 3, at least with my testing kind of on the TCP side of things, there's definitely some pretty significant performance differences. So to first order, iPerf 2 actually supports multiple threads, multiple processes. I guess it's multiple threads. iPerf3 seems like it doesn't.
Yeah.
So if you do the -p whatever, iPerf2 will actually use multiple cores. iPerf3 doesn't. So if you're just using one process, you can go way faster on iPerf2. But I think there's a bit of a trade-off in that iPerf2 uses like it's not as efficient as iPerf3 when you're just using a single connection, a single process. So it seems like you can maybe get a higher rate with iPerf3. You just need to do a little bit more work to run multiple instances in parallel to saturate some of these higher bandwidth links. So that's why I went to the trouble of, creating my parallel iPerf script,
Yeah.
which is a wrapper around iPerf3 for that reason. So I don't know how much that might affect some of the measurements that you're looking at. It might make sense to try with iPerf3, even if, it doesn't support the multiple processes because it's, higher throughput. And now we start to see why there's so many darn tools. One tool doesn't do what you want. Hey, we'll make our own darn tool. Well, at least it's a good thing that iPerf2 is still around and still installable, now that iPerf3 is available. So, I mean, hey, there's nothing wrong with needing both. If they have certain advantages, why not?
Yeah. So we'll have to dig in that area and come up with results next year.
Right. Oh yeah, I guess the other thing about the way the test setup that I have is put together is that it's set up such that the computer that you're running the test on, it doesn't need to, SSH into the machine that hosts the link partner NIC or something like that, right? So all of the statistics and information and whatnot is all collected off of the node that has Corundum running in it. I'm guessing you could probably do much more complicated tests and whatnot if you're, running code on both ends. But kind of for simplicity, I didn't have that kind of layer of configuration, right? We could run the whole test from one end of the link and then have the other end just run, a bunch of iPerf processes that we can poke at, that simplifies things. So if we wanted to do a more comprehensive test, I guess we might need to move away from that model. So I'm not sure with the test that you have, I'm guessing you're running stuff on both ends of the link, or it's looped back to the same box, I guess. Right?
Yeah, different scenarios. So basically it's point to point, two either two machines point to point running iPerf server or client or both in multi-directional cases, bi-directional cases. But we're also considering the other setup. We talked about this already, kind of a bridge mode where a machine with MQNIC driven card acts as a bridge in various scenarios and kind of taking packets from a source and sending them to some sync, maybe the same machine. So in the end, just two machines. But these are the same basic scenarios. So point to point and over a bridge.
Right. Well, I was
and QNIC being the bridge.
Right. Yeah. So I was thinking more just in terms of your test automation and how many hosts you actually need to connect to for setting things up and running the test. So when you're running the test with your lab automation thing, I'm guessing you have to connect to both machines, right? If you're doing a test across two computers where you have Corundum in one machine.
Now I get it. Yeah. Okay.
Yeah.
Yeah.
I'm guessing you have to connect to both of those, right?
Yeah.
Okay. Yeah, because that's, I guess in terms of trying to keep things simple, I didn't try to implement anything like that. Because in previous versions of the test, you had to have SSH keys all set up such that you could, SSH into other machines and run stuff. And it made everything quite complicated just for that management aspect.
Yeah.
So the way the current thing is set up is, well, and then also because you got to run stuff as root. So you can't just SSH into another machine. You have to SSH into another machine and then sudo to root or SSH in as root or something like that.
Mm,
And for
yeah.
the shared machines that we have at UCSD, that's difficult to automate. So,
Yeah.
So yeah, the way the test script is set up is that you can, manually SSH into the machines on the ends, and then you just run the PI perf script on one, and then the test script on the other one, and then everything works. And you don't need to configure, who's SSHing into what, and both the authentication and privilege control and whatnot. It kind of cuts that out of the picture. But I guess that does definitely limit what you can do with the test. Because you're not necessarily directly talking to the machine on the other end. So I'm not sure if there's any better solution for that I haven't thought of yet. Maybe we need yet another tool.
Yeah, of
iPerf
course.
doesn't work. iPerf 2 doesn't work. Well, let's make the next version of that can do some of these more complicated tests and run multiple processes and report back over the same link. So you can just leave that running on the other end.
I mean, in terms of lab setup, LabGrid is, I think, a good tool here. I mean, it has its drawbacks, also its disadvantages, as everything has. But we have been using it quite a while now, and it's.
No, it sounds like a good tool,
great.
and it seems like it could potentially make sense for some of the development machines that I have here, but I know our sysadmin pretty well. We could probably set it up on the shared machines at UCSD too, but it may be a little bit I don't know. I'm not sure it's the most appropriate solution for those, because everybody else who's doing stuff on there is just SSHing into the machines directly and doing stuff. So I don't know how that mixed mode of operations would work with something like LabGrid. Maybe it doesn't matter as long as you're careful about who's doing what, and you don't have fighting over the machines at the same time.
Right. Yeah. So I mean, LabGrid is just offering a kind of an abstraction. So you basically have a machine that's then called a place, and you acquire that place, and then you can work on it. Basically, SSH into it, and LabGrid has the credentials. So the user of the LabGrid client does not have to know the credentials to log in, for example. But of course it does not enforce anything. If somebody SSHs into the machine separately, then well.
Right. Yeah, I was just thinking it makes a lot of sense for hardware development, but the machines that we have at UCSD are mainly set up for software development and that kind of experimentation. So I don't know, something to think about. Not something I've had time to look into at all, really. Anyway, let's see. Is there anything else that we need to discuss, or have we covered all of the topics that people want to bring up? No, I think nobody wants to. Nobody has anything they want to bring up. All right. I guess that about rounds it out for the meeting today. Yeah. All right. Right. And like I said at the beginning, we're going to skip the next one. 2 weeks would be January 2nd, but I'm guessing that's going to be a problem for some people with the new year and whatnot. So the next meeting will be the 16th, right, which is the third week of January there. So, all right, I guess we'll see all you guys next year.
Yeah.
Thanks for tuning in.
All right. Thank you.
Have a good time over Christmas, and
Merry
see you
Christmas.
next year.
Yeah, happy holidays, Merry Christmas, Happy New Year. and so on and so forth.
Happy
And what other
debugging.
holidays are going on? Happy debugging. Yeah, that's always important.
Yes,
Oh,
it is.
speaking of debugging, if you guys are aware of rubber duck debugging, I just got a new rubber duck for debugging. Actually, it's part of a Lego set. I saw it and I'm like, okay, that thing is hilarious. It's like some little stunt guy on a bicycle and it's all rubber duck themed. So I'm like, okay, that's perfect for debugging. All right. Well, with that said, we'll see you guys next year. Take care. Have a nice holiday, nice new year, so on and so forth. All right.
Okay, you too. Bye.
Likewise.
Goodbye, gents.
Bye.
All right. Talk to you.